Hello everybody, it's Mr. Potynski. I'm going to be going over the least common denominator when adding and subtracting rational expressions. So you've probably seen this before in your elementary school classes or middle school maybe. So we have two methods that we're going to talk about when adding and subtracting rational expressions. So the first one looks like this. Say I want to add these two rational expressions together. What I want to do in order to get a common denominator is just multiply by the other denominator to the other rational expression. So like this. I multiply by 3 squared over 3 squared to our left-hand rational expression. And then we're also going to multiply by 3 over 3 to our other rational expression on the right there. So then our common denominator is going to come out to 3 cubed. And we can just simplify. So all 3 squared over 3 cubed plus 3 over 3 cubed. Then I just have to simplify. So that's going to come out to 3 squared plus 3 over 3 cubed. If I pull out a 3, I'll have 3 times the quantity of 3 plus 1. That's over 3 cubed. One of those 3's are going to cancel, so I'll be left with 3 squared in the denominator, and then 3 plus 1 is 4. So 4 over 3 squared. It's kind of all over the place, but there's our final answer. We got to it. Our other method over here, method B. Same problem. So I want to add these rational expressions together. However, I'm going to stop, think about it for a second. I'm going to see that 3 squared, I can get to that just by multiplying 3 to my other denominator, so I can get a common denominator of 3 squared. So if I do that, multiply by 3 squared, I'll get 3 over 3 squared plus 1 over 3 squared. And that's going to equal 3 plus 1 over 3 squared, which is 4 over 3 squared. So we got to the same answer here and here, but we did it different ways. So this is with just numbers here. So if we throw in some variables, that's what we'll be working with when we do some rational expression and rational functions. So, and we'll do each method for each one. So say I have a desire to add one over x plus 1 over x squared. I want to add those together. With this first method, I'm going to multiply by the other rational expression denominator over itself. Just like that, so I'll get a denominator of x cubed. Once I simplify, and then we can add, because we have a common denominator. So we'll have x squared plus x over x cubed, and then I just have to factor out an x, and then I can cancel one x, so I'll be left with x plus 1 over x squared. So that's once again that other method. This method here where we multiply by the opposite rational rational expressions denominator. Now, method B, do the same thing. I'm going to take a look, see that x squared, I can just multiply an x to get to that, so we'll have a common denominator there, times x over x. I'll be left with x over x squared plus 1 over x squared. Now I can add x plus 1 over x squared. Okay, so these are our two methods for adding and subtracting rational expressions with a least common denominator. So these two examples were pretty easy. But here's an example that might be a little bit harder. Okay, so I want to add these two rational expressions together. I want to find the least common denominator. So I could do the first method, method A, and simply, it's our red method, I can multiply by x plus 1 over here, x plus 1, so x plus 1 over x plus 1, and then times x squared minus 1, x squared minus 1. Could do that. In this case, our least common denominator would be x cubed plus x squared minus x minus 1. So that's a viable option. We would just have to simplify them. However, you might notice as well that if I change my left-hand rational expression here, that I could maybe do something a little different. So if I rewrite it like that, because I factored this difference of squares, so x squared and then 1 is also a square, and there's a minus sign in the middle, so I know that my factors are the square root of each of those separated by a plus and then a minus. I can see that x plus 1 is already a factor over here, and I already have that over there. So if I want to get this to be a common denominator, I just have to multiply by x minus 1. This is our second method. So then we will simplify. And then we just have to add. So we'll be left with 1, don't forget the 1 either, 1 plus x minus 1. So we'll just be left with x over x plus 1, x minus 1. Okay, so using our second method, we can see that this is indeed easier in this circumstance. However, so the first method can be helpful if you can't figure out the factors. Like, I knew the factors of this, so I was able to see that they do line up in some way. However, the factors weren't the same in any way. So imagine this is imagine that's a 9 instead of a 1. Then my factors are x plus 3 and x minus 3. In that circumstance, if I want to add this expression with that one, I have to multiply the entire denominator by this fraction, this rational expression, and multiply x plus 1 over x plus 1 times this one. So that's where we would use A. So when we don't have any common factors or expressions that we can use to cancel something out. But usually it's best to just break it down into these components. So if I had like this, x squared minus 9, it's easy to break down to these components because I can easily use these to see if anything lines up or if I have to multiply anything. I don't have to do the entire expression, hopefully. But yes, so this is adding and subtracting with a least common denominator and the methods that we can use in order to find a sum or find a difference. So now you'll have some time to complete the problems below this video if you are watching. So thank you.